So on compound, proportion, and rates of work, you have been told that there's a tank that has to get filled with two taps. And as well, unfortunately, there is another tap that does the emptying. So we are told to calculate the exact time that the tank is going to get filled if all those three taps are going to be opened. Two filling the tank and as well one emptying the tank at the same time. So we will be able to first have this question getting summarized. So this is your online tutor, Mr. Ngata. So we have actually been given that there's a tap A that takes 3 hours to fill this tank when working alone. There is another tap B that does the filling of this tank and it does this in 2 hours. There's a tank that has to get discussed here, and the same tank is told to have a tap C that does the emptying in 6 hours. So you're told that these taps can take these times when working alone. So you can try to imagine that the first tap A does the filling of the tank, and it actually does that in 3 hours. The other tap B does the same work that A does, that is filling, and it takes a maximum of 2 hours. But there's this third tap that is labeled C, and this tap takes 6 hours to empty this whole tank, and the tank is full. These are the respective times that these taps take when working alone, either to empty the tank or to fill the tank. So then we are told that A and B, as the two taps filling the tank, take 5 hours before C gets opened. So we need to ask ourselves, in the 5 hours A and B have actually been opened, how much work do they do? Which fraction of the work do they end up doing? So we come here and say, in 1 hour, we shall actually be able to have A and B doing a particular fraction of the work. Okay? So if A takes 3 hours and B takes 2 hours, then how do you get the work done? You always have to pick the time taken by any of these steps, then get the reciprocal for you to get the work done. So if it takes 3 hours, then that means it does 1/3 of the work. Then if this B takes 2 hours to fill that same tank, then the work it does is 1/2. So the summation of these two can give us the work done by these two taps in 1 hour. So this is going to be, our LCM is going to be what? It's going to be 6. So that is 2, then plus 3. So they will do 5/6 of the work. So 5/6 as a fraction in terms of the filling of that tank gets done. Remember, so if A and B are opened to work, then in 1 hour, they are able to do 5/6 of the work that has to get done in terms of filling that tank. And that can actually serve as our first part of that question. And then the second part is telling us that A and R are opened for 5 hours. And they're asking us to get the fraction of the work that they actually end up doing in the 5 hours given in the question. So I know very well A fills but R empties. We can be able to say A fills and C empties. So then, let's first ask ourselves, in 1 hour, how much work can they do? Which fraction of the work can they do? Then what about 5 hours? Then we can see which fraction of the work remains undone. So A and C are open for 5 hours. How much work gets done and how much work remains undone in filling the tank that you're actually getting given in this question? So A takes 3 hours. So the fraction it does in 1 hour is 1 over 3. Then we shall not say plus because C is empty. So this fills, this also fills, and this empties. So A fills, B fills, and C empties. So if A takes 3 hours to fill the tank, then it actually does 1 over 3 of the work in an hour. We shall say minus how much work does C do in emptying the tank. If it takes 6 hours, then it does 1 over 6 of the work. Okay, let's see how much work gets done in 1 hour if A and C are opened, A filling and C empty. So the LCM is 6. So 3 into 6, that is 2. We shall say 2 minus 6 into 6, 1 times 1, that is 1. So 1 over 6 of the work is done in 1 hour by A and C. This gets done in 1 hour. So this is also done in 1 hour if A and B are open. And let's come back here. So if in 1 hour, 1 over 6 is done, what about in 5 hours? So that translates into 5 over 1 times 1 over 6. 5 times 1 over 6, then divided by 1. So it's just like the same as 5 over 1 times 1 over 6. So this gives us 5 over 6. So 5 over 6 is the work done in 5 hours. The work done in 5 hours. So 5 over 6 is what gets done in 5 hours by these 3 taps. So how much work gets left undone? So we shall say our denominator is 6. So we shall say 6 over 6 less 1 over 6. Okay, this is 5. Then we shall be left with what? 1 over 6. So 1 over 6 of the work remains undone by these 2 taps A and C. So if all of them are open, so this becomes our answer of the remaining work to be done. When A and C are opened for 5 hours, whatever remains undone is 1 over 6. Whatever gets done is 5 over 6. Whatever gets done in 1 hour by the 2 is 1 over 6. What about 5 hours? 5 over 6. From the total fraction of the work to be done, we shall remain with 1 over 6 as the work undone. Okay. Part 3. How long can these 3 tabs, if all are opened, take to ensure that this tank is full? So we shall say 1, yeah, that is correct. So 1 over 3, the work that A does, plus 1 over 2, the work that B does, minus 1 over 6, the work that C does. This is filling, this is filling, this is empty. So we shall say A plus B, okay, minus C. Very good. So in that regard, it means you're going to have A filling, so the work it does in terms of a fraction is a third from its work done oriented time, which is 3 hours. B takes 2 hours, so the work it does is a half. And C takes 6 hours, the work it does is 1 over 6. They say minus because it does the empty of this tank. So that you can get the LCM, and this is going to give us the work they can do in 1 hour if they're all opened. So our LCM is 6, so we shall have 3 into 6, that is 2, so we shall say 2 plus, then 2 into 6, that is 3, so we shall have 3 minus 6 into 6, that is 1, so we shall have 1. So that's 5 minus 1, that gives us 4 over 6. So this is the work they can do in an hour. So if in 1 hour they can do 4 over 6, then how long do they take to finish this work? Which work is remaining? The work remaining is 1 over 6 from this end. I think you can be able to see that. Because the question is asking us to get the time they will take to complete the remaining work. So if they are all working, they can do 4 over 6 in an hour. What about the remaining work, which is 1 over 6? Because 5 over 6 in 5 hours was done by A and C. So in 1 hour, 4 over 6. What about 1 over 6? How long can it take? for this work to get done. It remains as the done work in the first case after the A and C are opened for 5 hours. So we shall have 1 times 1 over 6, then divided by 5 over 6. So we shall have 1 times 1 over 6 times 6 over 1. Just get the reciprocal of that. So we shall have 1 times 1 over 6. Division changes to multiplication and get the reciprocal of this, which gives us 6 over 5. So this and this will disappear. So 1 times 1 times 1, we shall get 1 over 1 times 1 times 5. So they will take a fifth an hour to do the remaining work. And this is the same as taking 12 minutes. Just say 1 over 5 of an hour. So that's what they can be able to take in terms of finishing the remaining work, which is 1 over